and we're just going to spend a bit of time looking at the road ahead. So I will just move this out of the way. So this is, I updated this yesterday, I think. This is Esri's release plan, so the last few months, and this is the start of next year, the release plan. Rather than look at the detail, the important thing on this is we've got a real regular cadence now of updates. So ArcGIS Online is updated 4 times a year. It was due to be updated last night, but I don't know if you read this morning that Amazon had problems, and we rely on Amazon for some of the back end of ArcGIS Online. So we've had to push the delay out, the release out until, I think it's tonight, they're going to try again. And hopefully that will go well. But 4 times a year, ArcGIS Online gets updated. ArcGIS 2021, you can see here, that's a wrap up of ArcGIS Enterprise, ArcGIS Pro, and various ArcGIS solutions. And once again, that's released on a regular cadence. And you can see all the various products that just keep tripping along. And that's a big change from where we used to be, where we had major releases every few years. We just have this regular release cycle, which allows us to incrementally improve the products. And every few releases, we have a product which is focused on quality rather than new functionality, such as the recent release of ArcGIS Pro 2.9. Now next year, you can see that thing has been sketched out in more detail now, and these release plans go forward about 2 years, and the planning of them. In terms of what we're working on, this is a slide that shows sort of areas of interest and development for Esri. And I'll just step through a few of those, and then we'll go into a few specific areas. Esri has got a large development team. We have about 2,000 developers who work full-time on ArcGIS and the various products that are associated with it. And there's ongoing research. We invest a huge amount in research to sort of improve the tools that you have for doing GIS and sharing the output of it. So a few areas to sort of highlight that we're putting a lot of effort into next year. This one, cloud native. So increasingly, people are using cloud-based systems, either through software as a service like ArcGIS Online, or by directly accessing Azure or Amazon or other systems. And we're adding support for cloud-native databases, so like on Amazon's own services, Azure's own services, and Google stores. So we're starting to have better support for Google's cloud services, where you can store data natively in their online databases and then reach into them directly from ArcGIS. So a lot of work going on to that. Another area is Kubernetes over here. Kubernetes is a system for running cloud-based systems or any system on infrastructure, but it scales very easily. You can, there's a few cloud services, once again, Amazon, Azure, Google, all offer a Kubernetes service, and you install ArcGIS into that environment, and then it makes it very, very easy to scale that, both up and down, very, very flexibly and resiliently. Kubernetes and microservices is tied into Kubernetes. So in order to be able to scale out appropriately, we've had to break the capabilities of ArcGIS Enterprise into smaller services. So we can say, oh, somebody's doing a lot more work on a map service, so let's spin up just the map service part of it. So a few microservices for map production. If somebody's doing a lot of analysis, we spin up the bits for analysis and so on. Indoors and BIM, I'm going to talk about in a bit more detail. It's a major area of research. There's a small thing down here called Story Maps Express, which I'm going to talk on, but you can just see the sort of different sort of areas of focus that we're applying. Now, GeoAI is one I just want to touch on before I move away. Earlier on, Liz talked about the land cover map and how that's produced. If I can just skip across to that. This land cover map that is produced, I was going to sort of step back and think about what was involved in it. So it is a map of the entire planet down to a 10 meter resolution. And we've taken that land cover map and we've run it forward to 2050. We have created a map, which is this map showing here's what land cover will be like in 2050. If we don't change, it takes a little bit of time to sort of come in. And then we've created areas of risk and everything else. Now, this data is created by automatically pulling in satellite imagery, stitching it into a coherent map, and then running an artificial intelligence tool, which has been trained to look at that data, correct it, sort of infer things from it, and tell us here is the land cover of the whole planet. And that process is entirely automated. And I think Liz mentioned it happens over a few days, so we can take that imagery, and every few days we can create a new map. And that for me is one of the most exciting things about AI being applied to GIS, is we can automate at a scale that you simply couldn't do before. So we can have this data trickling in, and that frees up the GIS analysts for the understanding aspect. It's not the tedium of rectifying data sets, stitching them together, color correcting them, and then looking at them or doing analysis against them to see change and so on. This process is entirely automatic. So the GIS analyst role becomes, what do I want to do? What questions do I want to answer? How do I communicate them? Rather than the mechanics of how that thing is done. And then there's a lot of effort goes into refining these models. So at the moment, this is a 10-meter model. As better data comes on stream, we can go down lower and more fine-grained, and our predictions can be better. And if you apply that way of working to everything else, to other things, it's just, I think it's a revolution in the use of GIS. So we're putting a lot of effort into the application of AI to GIS. And most of this capability is available in online or in desktop or on-premise. So you've got the flexibility to work with it. But you can do an incredible amount of AI development, training, publishing, and so on, simply using a browser and nothing else, because you've got access in that browser environment to imagery. We added imagery this year, and there's more imagery coming into online. We added Python, obviously. You can work with Python environment, set up notebooks that you can schedule to run on a regular basis. It really is an incredible change. So going back to here, there's a few things I want to talk about in more detail. This is a product that we've just released called Geobim. What Geobim does is it allows you to go into various CAD drawings and plans and documents, georeference them, and bring them all into the GIS environment. So you're using the GIS to index and make sense of multiple sets of BIM type information or CAD type information. You're using GIS really as the index of all the various data sets that you have, because once you geocode all those separate documents that you might have, like, you know, in this case, the air conditioning system of a large building is stored in a CAD drawing. The design of the building is stored in a CAD drawing. There might be PDF files that you want to access and reference. You use GIS to stitch all these things together, and then you can say things like, show me what the effect of the electricity supply needed for this scale of building is, and so on. Over here, you can see where somebody has brought in a separate CAD drawing into it. And underground, you can see another set of CAD information. All of this has been united using GIS. So we've just released this. It links together Autodesk products with the Esri products in an online environment and allows you to stitch together those data sets. You're using GIS as the index onto other data sets and help make sense of them all. So that's an area we're doing a lot of development in. But just sort of following up on that, sort of, you know, as CTO, I quite often have interviews with journalists or whatever, doing various articles, and a common question, you're interviewing a CTO, so you ask a question of, what does the future hold? What's the most exciting thing? And the expected answer is AI or 3D or augmented reality, all of which are incredibly exciting, all of which we're working on, and all of which we will see aspects of improving and being delivered through the next year. But the thing that I actually think is the most innovative thing in GIS at the moment is its availability at scale, where ordinary people can use GIS to do things that previously were only available to experts, were only available to people with powerful systems, with lots of training, and with money. We can now deliver GIS capabilities to anybody on the planet at really low cost. And we can start using that capability to do things that we really, really struggled to do in the past. So let me just show you a thing called Express Maps. This is Express Maps. It is Esri's first ever business to consumer product. We're releasing it next year. It's in beta now. You can sign up for it. And I'm just going to go in and create a story. It's a really simple application. And it is based upon ArcGIS Online in the background, providing base mapping and storage capabilities and publishing capabilities, all of which we don't need to worry about now. So we can focus on, how do you make this accessible to a wider audience? Because GIS, I can't stress enough, is absolutely vital to helping our society manage and mitigate climate change. And we need it in the hands of people who are not us, you know, as well as us. We need to reach out wider. So here's me making a little story. I'm just going to say, let's say a year in review. I'm going to add, let's add an image, and I'm going to use Unsplash for images. Let's go into for Wales. Unsplash is a set of copyright-free images online. So here's a nice picture. Just add that in. So we have a nice picture to introduce our story. And then I could put a caption against that, or I can go in and I can say, let's create a map. And I'm going to make a thematic map. So first of all, where do you want to be? I'm looking at United Kingdom. Here is some data. There's a map. I'm going to type some numbers in here. So England has got 4. There's a bonus point for anybody who can tell me what these numbers represent. Scotland 82 and Wales on 7. So not as good as Scotland, but beating England, so that's good. And it's colored the map up, and I can place that map, I could add controls on it and so on, but basically I've created a thematic map really simply. I'm going to add another map to the system. Let's go and add an express map. Now I could use an ArcGIS Online map, a full web map that I've created before. I could use a map I've published from ArcGIS Pro and so on, but I'm just going to make a very simple drawn map here, and I'm going to go in and highlight an area, and I'm going to put some things on it and so on. Now this is trivial stuff, very, very simple functionality. You can do more with it. You can add names to it and link to other data sets, and so it can become quite complex, but it's very, very easy to use. Now, once I have this map created, and I'm in draft mode at the moment, I am going to go and design this thing. So rather than have this theme, I'm going to go for let's go for June, because it's a good film. And you can see how it's changed the color and the logos and so on. But what it's also changed is the color of the map itself. It's reached into the map, and it's able to change the symbology of that map to tie into the theme that I've got. This is really simple stuff, but it makes mapping so much more accessible to people on a wider basis. I also find it very useful as a GIS professional to have something where I can really quickly sketch something up and share it and have confidence that it's going to be usable on an iPad, on an iPhone, and everything else. So that's something I'm really, really excited about. But the last thing I wanted to touch on is here. So I've had to do a few presentations, especially around COP26, on the role of GIS on helping understand and manage climate change. And one area to look at was how to help people make better decisions in a city environment to manage the wider environment. How can GIS play a role in that? And the audience is mainly people who are not GIS professionals. They're IT professionals, they're data scientists, they are digital twin architects, and so on. They're not GIS people. So you can't talk with the language of layers and web maps and everything else. So it's a really interesting process. Is how do you communicate what we do to this audience without using the jargon that we dearly love, without using the product names that we use all the time. So this is just a quick run through of how I did that, just to stress the role of GIS and the role that you have in communicating to a wider community how to use geography in an appropriate way. So I'll just make this full screen. So what we have on this map is we have part of Edinburgh, and it's obviously a complex city. You can see a real mismatch of uses. We have open ground here, we have got playing fields here, we've got the Palace of Holyrood, I've got a railway station. It's a complex, dense environment. How do you make sense of this environment? How do you make decisions in this environment easily? So first thing I'm going to do is just change to a different base map, which makes things a little bit clearer. And what I have on screen is I have a digital twin of an electrical network. So these brown lines, that's an electrical network. And it's a system that allows me to ask questions of it. So I can say, where can I connect new cable to? If I put a cable in of this capacity, is there enough energy available on the system to cope with it? And so on. So I can ask that digital twin different questions. And I'm interested in laying a new cable to reach a new housing development or to add some sustainable power to the network and so on. And in this area, obviously, there's lots of constraints on what I can do. Now, my mouse I'm moving around, and my mouse is communicating where I'm interested in. It's a position. Now, if I move down here, you can see a series of lines come up. Now, these lines are telling me the distance to things that might be constraints to me designing it. So I'm going to follow those lines in, and I can see there's tree preservation orders here. A rowan tree, an oak tree. There's a digital twin held by the local authority of trees in Edinburgh. It tells us the size of them, the diameter of them, the depth of the root system. There's various sets of information stored in a completely separate database with all of the attributes required to understand and manage trees in this area. I also have down here a listed building. So once again, there's a separate twin, digital twin, which is recording all the listed buildings, and I can ask questions of it, like what level of protection there is. Down here, I can see contaminated land. Here's another listed building. Over here, there's a triple SI. And down here, there's an abandoned gas main. Now, just by the act of moving my mouse around the screen, I am communicating where I'm interested in, and I'm reaching in to different systems owned by different businesses and saying, if I do something in this area, what might it mean? Tell me more about it. That's the power of just simple location. So now let me go and create a new power line. So first thing, I have clicked the button and I've asked a question of the electrical digital twin and said, where can I connect a cable of this type? I've got different types of cables I can do. Where can I'll just take that overhead one. Where can I validly connect this? And it's showing me positions on a map where I can validly connect it. So I'm going to connect into here. And then I'm going to start drawing it. Now, what you will see as I start drawing is this comes up, a design report, and it's telling me the material cost and construction cost. Now, the material cost is I know how much it costs to buy cable of this type, and as I add length to that cable, then it's calculating the new material cost. The construction cost, that's the cost of digging up the road or the footpath or whatever other surface I'm digging on, and then replacing it. And the level I replace it to is defined by the local authority, who've got a map called a reinstatement category that tells me how expensive it is or what level of quality I need to reinstate the surface to. That digital twin of reinstatement areas is held by Edinburgh City Council, and each time I click the map, I'm asking a question to say, how much does it cost to basically dig a trench here and fill it into the right quality? And that's driving that cost. I'm not even showing those reinstatement categories on the map. I'm just simply asking a question. And the reason I'm able to do that is I'm using location to say, I'm in this area. What is a reinstatement category here? How much of it do I cross? What's the cost of doing it? And so on. And as I go through this and start, I'm just going to click randomly, not randomly, but in different places, you can see that I'm building up a constraints map down here. So it's found a tree preservation order. It's found 3 abandoned gas mains. It's found contaminated land listed building an ancient forest. So the very simple act of just drawing a line on a screen is allowing me to get advance notice of the impact of that decision, so I can make a better decision. Now I'm looking at this decision in isolation, as this city is a large, complex city. Geography allows me to index multiple different twins. The location I'm interested in allows me to pull in information from multiple places. Because I know that place, I know what else is happening around me, the context of it. So I can ask, if I'm making a decision here, what's that impact, not just on this individual decision, but across the entire city? So for example, if I was deciding to apply for permission to tarmac my garden so I can park more cars, that might be a fine decision for me in isolation, but over the city, it could be adding to a flood risk because of impermeable surfaces. So the council might want to either reject my proposal or to say, yes, but you need to have gravel, something like that. This is where location really helps. It enables us to stitch together different systems and ask questions of them. It is the cheapest, most efficient way of linking multiple data sets together to understand our world. So that's the sort of story and example that makes sense to people who are not steeped in the world of GIS. And we're able to do this because behind the scenes, we have systems which serve up data in very, very easy to reach ways. Simply APIs you can ask questions of. We can present it in nice, clean ways. We have the processing power now to do things quickly so they feel engaging and they communicate clearly. We couldn't do this without the technology we have today. It allows us to make GIS transparent. So we can do more than we were ever able to do. And that's what excites me most. And that's what Esri is continuing to work on. And the sort of presentations you've seen today and so on just shows that the capability which is in our community and the opportunity of communicating that better.